Today we're talking about quadratic equations, and what I want to emphasize today, not only will we be solving quadratic equations, but how to know which technique to use. The three main techniques are factoring, the square root property, and the quadratic formula. First of all, you recognize that you have a quadratic equation because it's a polynomial equation with the highest power on the variable being a 2. For example, over here we have 5x squared minus 10x equals 0. What I always think about when I first look at an equation is it easy to factor? Because if you can factor, it's a really quick and simple solution, and you might as well go ahead and do that. If you look at an equation and it's not simple to factor, you want to think about whether you want to use the square root property or the quadratic formula. And so there are two cases where we can very easily use the square root property. We have the case where we have no x term in the equation, like this one here, x squared plus 9 equals 11. Notice there's an x squared and there's some constants, but there's no x term like 3x or 5x. In that case, it's very easy to rewrite the equation in the form of x squared equals a number. Like in this case, we could subtract the 9 to the other side and we would have x squared must be equal to 2. And in that case, we can use the square root property, and I'll show you how we do that in a minute. The other case where you would use the square root property is when you have something of the form a quantity squared, like a binomial squared, equal to a number. Here's an example like that. So if we see 2x plus 1 squared equals 12, there's no need to go ahead and FOIL that out to multiply 2x plus 1 times itself, because we can actually just apply the square root property and be done a lot quicker. And then the third case, when you look at a quadratic equation and you don't see an easy way to factor it, and it has an x term and it's not factored into a perfect square equals a number, then in those cases, which is all the rest of the cases, you're going to use the quadratic formula. What if we were asked to solve x squared plus 9 equals 11? So you first check to see if factoring will work easily. Remember, for factoring, we need a 0 on one side. So I could subtract 11 from both sides, and I get x squared minus 2 equals 0. The 2 there is not a perfect square, so it's not a difference of squares. So it doesn't factor using integers. So instead, since we have no x term, we know that it's also easy to move the number to one side and to get the x squared by itself. So I'm going to instead subtract 9 from both sides, so we get x squared equals 2. And then if x squared is equal to 2, then there's two possibilities for x. X can be the positive or negative square root of 2. That's called applying the square root property. We're essentially reversing the squared operation by taking a square root, but we have to keep in mind that it could be a positive or negative square root of 2 that would satisfy the equation. So your solution set would have a negative square root of 2 in it, and it would also have a positive square root of 2 in it. Okay, both of these numbers are solutions. Okay, let's look at another one. For this one, we're asked to solve the quantity 2x plus 1 squared is equal to 12. All right, so it's very tempting when you see a quadratic equation like this one to square this binomial, but it actually just makes the work longer. So when you have a quantity squared equal to a number, something that fits that type of pattern, the easiest thing is to go ahead and use the square root property just like we did in the problem before. It's true that we don't have x squared here on the left, but it doesn't really matter. Remember, x is just a name for an unknown quantity. This unknown quantity has the name 2x plus 1. It's still an unknown quantity being squared. And if that number squared is equal to 12, then by the square root property, 2x plus 1, the number, the mystery number, could either be the positive or negative version of the square root of 12. So again, this step right here, this is key. This is where I'm applying the square root property. Now, a lot of times people think of it as taking the square root of both sides. I kind of discourage you from thinking of it that way, because when students do that, they often forget the plus or minus. All right, now we have some work to do. We have to simplify square root of 12. The method we've been using for simplifying radicals is to use the prime factorization. So let's find the prime factorization of 12. 2 goes into 12 6 times, 2 goes into 6 3 times. So 12 can be thought of as 2 squared times 3. So the square root of 12 is the square root of 2 squared times 3. The square root of 2 squared is 2, and that square root of 3 has to tag along there. We can't simplify that. It's irrational. So we now know that 2x plus 1 is plus or minus 2 times the square root of 3. But we want to know what x is. So we need to subtract 1 from both sides to help get x by itself. That would mean 2x equals negative 1 plus or minus 2 root 3. Remember, negative 1 and 2 root 3 are not like radicals, they're not like terms. We can't combine them, so they just stay glued together with that plus or minus. Now I'm going to divide both sides by 2, so x is equal to negative 1 plus or minus 2 root 3 all over 2. Now, if you have to write this as a solution set, you have two separate numbers, negative 1 plus 2 root 3 all over 2, and negative 1 minus 2 root 3 all over 2. I hope you found this video useful. If you did, please remember to like it.